Good afternoon. This is a class on engineering thermodynamics, and today's topic is quasi-static process. In the last class, definition of the system was discussed, and many other things. In this subject, all the processes will be considered as quasi-static in nature. Though we know that this process is actually an idealized process. Idealized process means this is an imagined process. This process does not occur in laboratory. This experiment cannot be done or cannot be conducted. This is just a thought experiment. Static means, you know, what is the meaning of static? When something does not move with respect to its surroundings, then it is called that object is in static condition with respect to the surroundings. And quasi means semi. Quasi-static means semi-static. Means neither the process is static nor dynamic. So the name of the process suggests that implies that this process is not actual. Still, this concept is used in thermodynamics. The question is why? Why this concept is used? Because the mathematics involved in analyzing such problems is very difficult. If you want to capture the actual processes, then mathematics involved for such process will be huge. That will be very difficult to solve mathematically. So, without sacrificing much accuracy, if use of simple mathematics is able to solve your purpose, to serve your purpose, okay, then that mathematics is most welcomed. In scientific research, as well as in engineering. And I think you have an idea about this process. Normally this process is shown by taking an example of a cylinder and a piston arrangement. So there is a vertical cylinder like this, okay, and there is one piston. And there is no friction in between the piston and the cylinder, frictionless process. This is also imaginary frictionless process. And inside that cylinder, some gas is there. Okay. Say for example, at certain time, the whole system is in static equilibrium as well as it is in thermodynamic equilibrium. You know something about thermodynamic equilibrium. When mechanical equilibrium, chemical equilibrium and thermal equilibrium are achieved simultaneously, then we say that the system is in thermodynamic equilibrium. So this is the system. The piston has certain weight and the gas inside the cylinder is exerting some pressure on the inner surface of the piston. Due to that pressure, a force is created, pressure multiplied by the area of the piston, that is the force. So that upward force and the downward force means weight of the piston. If they are same, then they will be in the static condition. Now, how this quasi-static process is taught? It said that a small weight, as small as possible. Say for example 1 gram, only 1 gram. Say weight of the piston was 10 kg, mass of the piston was 10 kg, means weight is 10 kg multiplied by G, 9.8, okay. And you just put 1 gram of mass. So accordingly you can calculate the weight multiplied by G. So you know that due to addition of that weight, there will be a downward movement of the piston. You know that this movement will be very small, very small will be this displacement. So there will be a decrease in volume of the gas due to the inward movement or the downward movement of the piston. And then allow some time so that the system, the whole system, the entire system reaches to an equilibrium condition again. Equilibrium condition means again that thermal equilibrium condition. When all those 3 equilibrium conditions are achieved simultaneously. And you take, and then you again measure the pressure, temperature, volume, etc. of the gas. So this is called what? If everything is known, then we say that the system exists in a certain state. Then again you put 1 gram of weight, 1 gram of mass, again you do the same thing. So this way quasi-static process is analyzed. Since there is motion of the piston, then there is again one pause. It is resting for some time. Then again you are putting some weight. Then again there is some motion. So this is why this process is called quasi-static. So our target is what? Our target is that when a system reaches from one state to another state, say from initial state to final state, the system passes through numerous or infinite numbers of states. You know that if say a sheet of paper, a paper is given, if 2 points are given on that paper, so to join the 2 points, infinite number of curves you can draw. And for these for thermodynamic processes, these curves will denote the process. But how you will draw the curves, infinite number of curves are there. So you need to know all the intermediate points. If number of points are more, then drawing the required curve will be easy. And if the curve or the path, this curve is the path followed by the system. If it is known, then only you can do the mathematical calculations. If this path is known. So our main purpose is what? Our main purpose is to get that path. Path in between the initial and the final state. If the path is not known, then that simple mathematics cannot be applied to solve such problems. That is the main purpose, to know the path followed by the system during reaching from one state to another state. That is the main purpose of conceiving such hypothetical or imaginary process. Just to know the states. Okay. You just keep in your mind that in actual practices, no process is quasi-static in nature. And by doing this, only rough estimates about any thermodynamical processes can be completed. So, this was all about quasi-static process. The purpose of this lecture is to just give you an idea about this process, the quasi-static process. And you know that much more processes are there, many more processes are there, isothermal process, adiabatic process, isocodic process, isobaric process, etc. Okay. And no, not and. In the next class, I'll finish this topic. In this class, I think up to this is sufficient. Okay. Thank you. You must go through your textbooks. Otherwise, just by attending this lecture, you won't be able to get all the points regarding any topic. After attending any class by any teacher, you must go through the textbooks. Okay, thank you.